What is motion theory? Everything we experience, matter, energy, forces, is just structured motion. Motion isn't just movement, it's the fundamental nature of reality itself. Traditional physics treats forces, particles, and time as separate things, but they're all just structured motion adapting to constraints. What is a photon? A photon isn't a wave or a particle. It's structured motion transferring synchronized motion from one system to another. It has no rest mass because it's not an object. It's pure motion. Its frequency is just its motion synchronization. Rate? Traditional physics says photons behave weirdly, but under motion theory they're just adapting to their environment. What is the Zeno experiment? A setup where we send a photon through multiple barriers. According to traditional quantum mechanics, the photon should have a probability distribution, interfering with itself to form a wave-like pattern. But what's really happening is structured motion optimization. What's actually going on? Motion theory explanation. The photon isn't choosing a path. It's not collapsing into a single position. It's not teleporting. It's redistributing its motion through the least resistant structured motion pathways. The reason we see gradual intensity shifts through the barriers is because the photon's motion energy is not instantly lost or fully blocked. It's dynamically adapting. This is the same pattern seen in electromagnetism and gravity, proving that all motion interactions behave by the same rules. This is the money shot. The Zeno experiment is not a probability game. It's a structured motion redistribution effect. You don't need wave-particle duality to explain this. You just need motion adapting to constraints. This video is the first real proof of concept for the world. More on the Zeno experiment in pure motion terms. The setup, structured motion in action. A photon, structured motion transfer, is emitted from a source. This photon is not a particle, not a wave. It is structured motion propagating through existing motion interactions. It follows the motion equilibrium of the system, adapting to constraints along the way. Key concept: all motion is structured and follows optimized redistribution patterns. Motion redistribution at the first splitter. The photon reaches a motion redistribution point, traditionally called a beam splitter. Here, structured motion adapts in real time. Part of the motion continues along its original path. Part of the motion is redistributed into a new synchronized motion trajectory. This isn't probability, it's motion rebalancing based on system constraints. The multipath motion synchronization. A series of motion redistribution points, splitters, creates multiple structured motion paths. The photon's structured motion does not choose a path. It exists across all synchronized motion trajectories. Left undisturbed, the photon's structured motion remains in equilibrium, producing an interference pattern at the final detectors. The key takeaway: the photon never travels as a discrete object. It is a structured motion adaptation unfolding through interaction constraints. The measurement effect. Motion disruption. When a measurement is introduced at any stage of the motion sequence, it disrupts the structured motion synchronization. This forces the motion system to adapt prematurely, collapsing into a singular trajectory instead of a multipath equilibrium. This is why interference disappears only when measurements interfere mid-process. No spooky wavefunction collapse, just structured motion forced into a lower adaptability state due to external disruption. Final. Motion theory interpretation wave-particle duality. A misinterpretation. Structured motion is neither. Photons don't collapse, they adapt dynamically to constraints. The observer effect is just motion responding to forced redistribution limits. Quantum mechanics isn't mysterious. It's structured motion optimizing pathways naturally. Motion theory's victory in the Zeno experiment. Traditional physics treats photons as both waves and particles, a contradiction. Motion theory eliminates this paradox by defining photons as structured motion in an adaptive equilibrium. The Zeno experiment visually confirms structured motion principles. It's not an abstract concept, it's what's actually happening. Notice how we're measuring the sequence of motion events, not time itself. Time isn't what's governing this. Motion adaptation is. Time is just our tool to track these changes. This experiment is the first major proof of structured motion in action.